My name is Anando Ghosh, and I chose to do a security camera with a monitor for my CNIT 176 Raspberry Pi project. When forming my proposal, I put together a rational set of requirements I wanted to fulfill. First, the project had to be within my current skill scope and doable within the remainder of the semester. I didn't want to bite off more than I could chew and tackle a massive project only to not get it working in time. The project had to be priced reasonably, nothing too expensive. I had set the maximum I could spend on extra materials to $40. The project had to be something I could use in real life, and not just to get a grade for the project. Finally, the project had to meet the instructor's requirements and level of difficulty. I originally presented 5 choices in my Pi proposal document: a motion sensor camera, a pirate radio, a fingerprint reader, a voice assistant, and a security camera and monitor. The instructor said that everything except the voice assistant was appropriate for the project. In the end, I chose the security camera since it met the set of rationales above and it seemed the most practical. How does this connect to the Raspberry Pi's architecture? Well, for one thing, the project involved fiddling around with the Pi's networking capabilities and operating system. For this project, I used a Raspberry Pi camera. It only cost me $20 to buy on Amazon.com. The camera's ribbon cable inserts into the connector situated between the Ethernet and HDMI ports. This is the Pi's CSI port, which stands for Camera Serial Interface. The camera is an input-output device transmitting video streaming data to the Pi, which is then handled by the Pi's operating system. The procedures I followed were elementary. I looked up multiple tutorials and information tidbits of how to get a camera connected to the Pi and monitor it. I compared resources with each step I took to make the project work. There were multiple ways I could set this camera monitor system up. One way was running raspi config and enabling the camera. If the option didn't appear, you probably need to run sudo apt-get update and sudo apt-get upgrade. Now this project can be done with issuing commands such as raspstill or rspid to capture video and images. But I found there were a lot of options to add a nice interface to improve interaction with the Pi. To do this, I could either copy and paste a script that set up a primitive interface with the camera, or I could get fancier and write a new operating system to the SD card that gave me a new interface with a lot of bells and whistles. Such things include settings to controlling the frame rate and resolution of the camera, as well as allowing things like motion capture. The Motion OS software is a complete operating system with the Raspberry Pi camera software included. In order to write this software to the SD card, I needed to format the card first, which meant erasing all previous data from the SD card. To do this, I found an SD formatter program online, and with the SD card adapter that came with the Raspberry Pi kit, I used my laptop to wipe the card to make way for the new software. The next program I used was called Win32 Disk Imager, which is used to write directly to the SD card. I downloaded and unzipped the Motion image file, which I then wrote to the formatted card with the Win32 Disk Imager program. At this point, I was done messing with the SD card. When I hooked up my Pi in the computer lab to continue working on it, I had assumed that the Wi-Fi connection done in the previous lab would be suitable to append the security camera to my laptop interface generated by the new operating system. However, when I tried to start up the Pi, it only kept running a few lines of code and rebooting itself, saying it was unable to find a connection. At this point, I thought I had already bricked my Pi until I took a closer look and realized that I would have to try an Ethernet connection. Wi-Fi could be implemented within the project with a Wi-Fi dongle, but I chose using an Ethernet method since I already had an Ethernet cord and sometimes the Wi-Fi connection could be down. This weekend, I went back home and used my parents' router Ethernet network, since they had fewer devices and it was easier to locate the Pi's IP address within the router itself. I could just go to the network tabs on my computer, log into the router, and the interface shows a nice list of addresses of devices on the router. Once I found my Pi's IP address, I entered it within my laptop's browser and I was able to access the Motion Eye interface from there. I didn't need to use PuTTY since my laptop and the Pi was connected physically to the router network. So this is how the final Raspberry Pi camera looked. I had to use a little bit of elbow grease and put together a Lego stand to position the camera so it looked forward. Rather than looking like a security camera, I guess it now looks more like a piece of modern art. In the end, I was able to shoot the following demonstration video showing that the security camera that was rigged in front of me works. The results were successful but limited. By this, I mean the camera and monitor worked, but I could only place the camera as long as the Pi's power supply cord and Ethernet cord could still be connected to an outlet. Things I could have done a little more differently were seeing if I could have utilized the Motion Eye system to Wi-Fi. This would get rid of having to have the camera near an Ethernet port. This is definitely a way I could go in the future. There is in fact a lot of potential expansion for this project, since the system allows things for like multiple Pis and cameras to be added, as well as setting up port forwarding or dynamic DNS. But right now I do have a working camera. My parents thought I would be using it to spy on them, but I figured it could be used for things like making sure no one gets into my room or watching something on TV from a different room. It was a fun little project to work on that certainly has potential to pave the way to other Pi projects in the future.